Hey guys, it's Alex. Today I want to talk to you about the heart, the anatomy of it, the mechanical action of it, and the electrical systems of the heart. Starting with the mechanical side of things and the anatomy, we have here a cross section of a human heart. Notice all the vessels surrounding the heart leading up to it. The heart you can think of as a pump. It's the pump of the body that moves all the blood through all the little corridors of the body, moving it to all the limbs and organs and nutrifying things and oxygenating things to help you survive. The blood starts in the right atrium here. Deoxygenated blood comes from the body down through the superior vena cava, which is the top vein here, and this is the inferior vena cava, which carries deoxygenated blood from the lower half of the body up into the right atrium here. It then, once it is full, it then moves through the tricuspid valve here, pushing blood into the right ventricle. The tricuspid valve will shut so that blood can't go backwards. And once the right atrium is full, blood will then be moved up through the pulmonic valve into the pulmonary arteries, which are the only arteries in the body that carry deoxygenated blood, to the right and left lung via these branches here. These are your pulmonary arteries. Once the blood has passed through the lungs, the hemoglobin has grabbed an oxygen molecule. It then comes back through the pulmonary veins, which on the other vice versa, they move oxygenated blood through the veins of the pulmonary veins into the left atrium here. These to the left atrium, which then moves through the bicuspid valve here after the atrium's full into the left ventricle. This valve closes so that blood can't move back into the lungs. Once the left atrium is full, it pushes blood through the aortic valve into the aorta and pumps oxygen and nutrients throughout the body. These first arteries stemming off of the aorta are the coronary arteries, which bring blood immediately back to the muscle of the heart so that it can function properly. This part of the heart is known as the intraventricular septum. It just divides the right side from the left. These are the walls of the heart here. Notice how the right side is much thinner than the left. And the reason for that is the right side only has to move blood up through into the lungs versus the left side, which has to move blood throughout the entire body. So it takes a lot more muscle to move blood through the entire body than it does just to move blood through the lungs. This part of the heart, the bottom, is known as the apex. I want to now talk about the electrical conduction system of the heart. The heart muscle is pretty special in that it's all electrical. It can run separately from the brain on its own impulses generated from this SA node here, which maintains an impulse of 60 to 100 beats per minute for your entire life. The pulse is generated here and it moves through intranodular pathways to the AV node, which is the second most important node of the heart. Through that, it moves into the bundle of His, down through the septum into the right and left branches. from there it moves further down the heart into the Purkinje fibers, which branch into the right and left wall of the heart. And that's where the contraction of the ventricles takes place. The pulse is, starting here, moves progressively slower and slower throughout the heart. If the SA node quits, then the impulse will start from the AV node, and if that quits, it'll be generated through the septum in the right and left branches, and then if that quits, the fibers will take over and attempt to continue pumping the heart. Now the nervous system is connected to the heart through the medulla oblongata, which maintains your heart rate. The sympathetic nervous system and the parasympathetic nervous system, which can be thought of as like gas and brake pedal, which are being used simultaneously. The sympathetic nervous system is responsible for increasing your heart rate when you have a stimulus from the environment. It can give you the fight or flight mode, which your body gets ready to respond when it needs to, when action needs to take place. The parasympathetic nervous system is responsible for cooling down the heart and its systems. It will decrease the heart rate and cause your body to slow down. That's how the nervous system is interacted with the heart muscle. I hope this is helpful. This is my explanation of it all. That's it.